Hello guys, welcome to Science Learning Gateway. I hope you all are doing good. So today I came up with a new video for you all for class 10 students, those who are going to write their exam after few days. Right? So in this tutorial, we are going to discuss some of the very important questions from chapter number 5, periodic classification of elements. In this tutorial, we are going to discuss some of the application based questions which are asked in the previous years. So I have collected few questions from the previous years also and from the sample paper which was issued by the Karnataka State Board also. So it is very important for you all. Please go through these questions, and if you have any doubt, you can comment in the comment section. And moreover, I will give you a brief explanation about the chapter periodic classification of the elements at the last of the video. So please go through the video till the end. So let's start with our discussion. The first question which we have over there is the following diagram. One diagram is given over there, and this question is there in your NCERT textbook also, and many times this question was asked in the board exam also. So let's discuss this question. The following diagram shows a part of the modern periodic table containing first three periods. You can see in this diagram three periods are given: period number 1, period number 2, and period number 3, in which five elements have been represented by the letters A, B, C, D, E. And you can see the five elements are also there: element A, element B, element C, D, and E. Select the letter and write which represent in alkali metals. So alkali metal, guys, alkali metals are present in which group? Obviously, alkali metals are present in group number 1. All the elements which are present in group number 1 are called alkali metals. So in this diagram, in group number 1, which elements are there? Element number A and element number D are present in group number 1. So these are the alkali metals. So in answer, we will write that A and D are alkali metals. Okay. The next question. Select and write the letter which represent an inert gas. Inert gases. Which group represent inert gases or noble gases? Group number 18, the last group. Last group represent the inert gas or the noble gases, like helium, neon, argon, krypton, xenon. Those all elements are present in group number 18 and are called inert gases or noble gases. So in group number 18, which element is present? The only element which is present in group number 18 is element number C. So it represents an inert gas. Next one is write a type of chemical bond formed between A and E. Okay, what type of bond will be formed between element number A and element number E? Since you know that element A is present in group number 1, it will have one valence electron, and this element number E is present in group number 7. How many valence electron it will have? It will have 7 valence electron. So what A will do? It will transfer its one electron to element number E, so that E will get a stable electronic configuration. So transfer of electron is going on over there. So which type of bond will be formed in between A and E? Ionic bond. Ionic bond will form between element number A and E. Since A is a metal which transfers one electron to a non-metal, that is your the element which is present in group number 17. So they will form a ionic bond. So answer of the third question is ionic bond. Ionic bond, which is formed by the transfer of electrons. So that's all about this question number 1. I hope this question you all have understood. It's very easy. In answer number A, alkali metals, you will write A and D. And in answer inert gases, you will write element number C. And in this one, you will write ionic bond. Ionic bond. And one more question which can be added in the exam, that what type of ion element number A and D will form? So they will form cation, that is positive ion, because they can lose one electron to form a positively charged species. So they will form cation. And this element number E, it can gain one electron to get stable electronic configuration. So it will form a negative ion called anion. That's all. Now let's discuss question number 2. See, in question number 2, this question is also given in your NCERT textbook. Nitrogen, you all know that the atomic number of nitrogen is 7, and phosphorus, atomic number 15, belong to group number 15 of the periodic table. Write the electronic configuration of these two elements. Which of these will be more electronegative and why? So first of all, we have to write the electronic configuration of nitrogen and phosphorus. Atomic number of nitrogen is 5. So in the first shell, 2 electrons will be present, and the rest of the electron will go into the next cell, that is 3 electrons. Now for phosphorus, atomic number is 15. We'll write the electronic configuration. The first shell 2 electrons, second shell 8 electron, and the rest of the electron will go into the next shell. 2, 8 and 5. So this is the electronic configuration which was asked in the question. Next question which is asked over there is which element will be more electronegative and why? Obviously nitrogen will be more electronegative. Why nitrogen is more electronegative? Because it is containing only two shells, shell number 1 and shell number 2, and since two shells will be more closer to the nucleus, therefore attraction for the nucleus will be strong. So therefore the attraction for the electrons with the nucleus will be strong. That's why nitrogen is a more electronegative element as compared to phosphorus. And when you move in a period, when you move in a group in a periodic table, electron attracting tendency decreases as we move from top to bottom. You know that nitrogen will be at the top and phosphorus is bottom. So when you move from top to bottom in a group, electronegativity decreases. So obviously nitrogen will be more electronegative as compared to phosphorus. And one more point you can remember, that in nitrogen two shells are present. So nucleus is very close. The attraction power of the nucleus for the electron will be very strong. That's why electronegativity of nitrogen will be more as compared to phosphorus. So in this question they can change the elements also in the exam, but remember that when you move in a group from top to bottom, electronegativity decreases, but when you move in a period from left to right, electronegativity increases. Next question is question number 3. This question is also asked in board exams many times. See, the position of three elements A, B, C. They have given us three alphabets A, B and C in the periodic table as shown in the figure. In group number 16, element number B is present, and group number 17, A and C is present. So we have to say that whether A is a metal or a non-metal. As you can see that element number A is present in group number 17 and it is present on the right side of the periodic table. So element A is a non-metal because it is present in group number 17. Right? And moreover, if we talk about its valence electron, it will have 7 valence electrons. So it can't be a metal. It is a non-metal because it is present in group number 17. Next, state whether C is more reactive or less reactive than A. A and C, they both are present in the same group. So we can say that C is less reactive as compared to A because reactivity of nonmetal decreases when we move from top to bottom in a group. When you move from top to bottom in a group, in case of nonmetal, reactivity will decrease. So C is present at the bottom, so its reactivity will be less as compared to A. So these questions, guys, you have to think and you have to write the answer. Application based questions will obviously be asked in the exam, so you have to remember the trends, that in the group which trend we have to follow and in periods which trends we have to follow, and just think and write the answers. Moreover, you should also know that group number 1 elements, they are called alkali metals. Group number 2 elements are called alkaline earth metals. Group number 17 are called halogens. Group number 18 elements are called inert gases. Those things you should remember. Will C be larger or smaller in size than B? B and C, they are present in the same period. So we have to say that C is larger in size or smaller in size than B. So C is smaller in size than B. Why? Because they both are present in the same period, but when we move from left to right in a period, what happened? Atomic radius or size decreases. Atomic radius or size decreases because of effective nuclear charge. Okay, the nucleus will attract the electron towards itself, and because of that the size of the particular element decreases. So among B and C, the size of element number C will be less as compared to B, because when you move in a period, the atomic size decreases. So that's all about question number 3. Now the next question is state Dobner's law of triads. This type of questions are also asked. Sometimes they will give you state Dobner's law of triads. Sometimes they will give you state modern periodic law. Sometimes it can be a state Newland's law of octaves. Right? So the statements and the laws which are given in chapter number 5, periodic classification of element, it should be clear to you all. So let's discuss what is Dobner's law of triads. So what Dobner did, he has arranged 3 elements A, B and C. Suppose three elements are there. He has arranged the three elements in a triad. Triad means three elements in the order of increasing atomic masses. How he has arranged the elements? In the order of increasing atomic masses. Suppose its atomic mass is 7, it is 9, it is 10. So he has arranged the elements in the order of increasing atomic masses. And what he has seen, that the atomic mass of the middle element was roughly the average of the atomic masses of the other two elements. Okay, so this was the concept of Dobner's law of triad. What he did, he has arranged the three elements in a triad in group of three, and he has arranged the elements in the order of increasing atomic masses. Remember that increasing atomic masses he has arranged. And what he has seen, that the atomic mass of the middle element was roughly the average of the atomic masses of the other two elements. So this was the concept of Dobner's law of triads. Now let's come to question number 5. So in question number 5, what is given over there is the electronic configuration of element X is 28811. One element is there whose electronic configuration is 2, 8, 8, 1. Means one electron is present in the valence shell, and one more element Y is there whose electronic configuration is 2, 8, C. So what type of bond is formed between these two elements? By looking at the valence electron, you can easily say that which type of bond is formed. X, what it will do? It will donate its one electron to Y, so that X will also become stable and Y will also become stable. It will gain 8 electron in the outermost shell, it will become stable, and Y will also accept one electron, it will also have 8 electron in the valence shell, and it will also become stable. So both the elements will become stable by transfer of electron. X will donate its one electron to Y to become stable, and they will form a ionic bond. Bond is formed by the transfer of electron. So in this question, ionic bond is formed. Next we have question number 6. Observe the given table and answer the following questions. Over there we have element A, B, C, D, E. And their atomic numbers are also given. Element A is having atomic number 11, B is having atomic number 4, C is having atomic number 2, D 7 and E 19. So on the basis of this, one question is asked over there. Identify the two elements that belong to the same period and two elements that belong to the same group. Give reasons for your conclusion. So see children, whenever you have this type of questions are asked, application based questions are asked, atomic number will be given in the question. Just one thing you have to do first is that you have to write the electronic configuration. If you will write the electronic configuration, you will understand that which element will be present in which period, what will be its valence electron, what will be the valency, everything will be it will be clear to you by writing the electronic configuration. So first thing is that you should write the electronic configuration. I have already uploaded a video for how to write the electronic configuration. You can check that in the playlist of concepts of chemistry. It will be very clear to you all. Now, first of all, what we will do? First of all, we will write the electronic configuration. The electronic configuration of element number A is 281. 2 electron in the first shell. Second shell contains 8 electrons, and the remaining electron will go into the next shell. On the basis of this, we have written the electronic configuration. Now we have to check that in which elements the shells are common. You can see in element number B and element number D, 2 shells are present, 2, 2 and 2, 5. In the first shell 2 electron, second shell 2 electron. In this first shell 2 electron and second shell 5 electron. These two elements are having 2 shells, that is common. So both element number B and D, they will be present in the same period. And which period they will present? They will be present in the second period because they contain 2 shells. Okay, if the element will contain 4 shells, for example this element number E, it will present in the 4th period. Suppose element number A, it contains 3 shells, 281 we have written, so it will be present in the 3rd period. But over there the question is asked that name 2 elements which are present in the same period. So element number B and D will be present in the 2nd period because they contain 2 shells. Now we have to answer that which element will be present in the same group. So for same group, what we have to see, that the number of valence electrons should be common. So let's see that which elements are having same number of valence electron. Element number A and E, they are having same number of valence electron. Valence electron means the outermost electrons, outermost shell electrons. They both are containing 1 electron. So they are present in which group? Group number 1. Okay. The valence electron will decide that the particular element will present in which group, because in a particular group, all the elements, they will have the same number of valence electron. For example, the elements which are present in group number 1, alkali metals, they all have same valence electron, that is one electron. The elements which are present in group number 2, they will have same valence electron, that is 2 valence electrons. So that was the answer of this question. Now come to question number 7, 8, 9, 10, 10th. Now see, in question number 7, how does the atomic size vary in a group and period in the modern periodic table, and why? This is also one of the most important question from your reasoning side. Okay, so what is the trend of atomic size in a group or in a period? So first, just let us discuss for a group. When you move from top to bottom in a group, when you move from top to bottom in a group, how many groups are there? Group 18 groups are there. So when you move from top to bottom in a group, what happened? Atomic size increases. Size increases. Atomic size increases. And why atomic size increases? Because new shells are added. When you move from top to bottom in a group, new shells will be added. One shells will be added for each of the elements. Suppose A, B, C, D, E element is there. So for first element, the size will be different. When you move to element number B, one more shell will be added. So its size will become little larger. Then it will become little larger. And when you reach to element number D, one more new shell will be added. So its size will become large. So when you move from top to bottom in a group, the atomic size increases. Why? Because number of shells increases. New shells are added. And the distance between the nucleus and the valence shell increases. That's why the size will also increase. Now what is the trend along a period? So when you move from top left to right in a period, the atomic size decreases. What is the reason for that? Why does the atomic size decreases when we move from left to right in a period? Because effective nuclear charge increases. Remember this point, that effective nuclear charge increases and over there new shells are added. When you move from left to right in a period, effective nuclear charge increases by 1 unit, because of which what the nucleus will do, the nucleus will attract, it will pull the valence electron towards itself, and the size will decrease. Suppose element number A, B, C and D, the size of element number A will be bigger, but as we move from left to right in a period, the size of element number D will become small because of effective nuclear charge. The distance between the nucleus and the valence electron will decrease, and their size will also decrease because of that. So this is a trend. When you move from top to bottom in a group, atomic size increases, and when you move from left to right in a period, atomic size decreases. Now we will discuss state modern periodic law. So this is also one of the important questions. The physical and chemical properties of elements are the periodic function of their atomic numbers. In Mendeleev's periodic table, what we have read, that the physical and chemical properties of elements are the periodic function of their atomic weight or atomic masses, we have read. But in modern periodic law, what is that? The physical and chemical properties of the element will depend on atomic number. Okay, our periodic function of their atomic number. So remember the statement of modern periodic law. Now what are metalloids? Give some example. You have seen that in the periodic table one zigzag line is there which separates the metal from the non-metals. If you can look at the periodic table, you can see over there one zigzag line is there which separates the metal from the non-metal, and that zigzag line in which some elements are there, that are called metalloids. So what are metalloids? Metalloids are those elements which have some properties of metals and some properties of non-metals. Means they will behave like metals also and they will behave like non-metals also. Examples of metalloids, you can write boron, you can write silicon, antimony, arsenic. These all are called your germanium, Ge. These all are your metalloids. So remember the definition of metalloids. Metalloids are those elements which have some properties of metals and some properties of non-metals. Example, boron, silicon, germanium. 2-3 examples are enough for you all. Now let's discuss question number 10. The atomic number of two elements are 12 and 16 respectively. Two elements are there, 12 and 16. So this will be a homework for you all. Can you tell me that atomic number 12, can you tell me the name of the element which is having atomic number 12, and can you tell me the name of the element which is having atomic number 16? So if you know the answer, please comment in the comment box that which element is having atomic number 12 and which element is having atomic number 16. Do you keep these two elements in the same period of the modern periodic table? This is one of the questions for us. Justify your answer. Which one of these elements is more electropositive and why? So see, first of all, we have to do the same thing. We have to write the electronic configuration for it. element with atomic number 12, we have written the electronic configuration 282, and for the next elements with atomic number 16, we have written the electronic configuration 286. Yes, both the elements are present in the same period because they both have 3 shells. So they are present in which period? In the third period, because the number of shells are same. Now, which element will be more electropositive in nature? Element with which is having atomic number 12 will be more electropositive because it is having 2 valence electron. It's a metal, so metals are more electropositive as compared to non-metal, and atomic number 16 element is a non-metal. So obviously element with atomic number 12 is more electropositive because it is a metal and it can donate its electron to form positive ion. Okay, so that's all. 10 questions I have discussed over there. I hope you have understood all the questions. Moreover, I want to give just a brief review about the chapter. See, Dobnius triad already we have discussed. If the question will be asked that state Newland's law of octaves. Newland's law of octaves. So what statement you will write for that? Please remember the answer for Newland's law of octaves also. When the elements are arranged according to increasing atomic masses. What Newlands did? He has also arranged the elements according to their increasing atomic masses. And what he said, that the physical and chemical properties of the first element was similar to the physical and chemical properties of the eighth element, just like a musical note. Correct? So Newland's law, according to Newland's law of octaves, he has arranged the elements in the order of increasing atomic masses, and the property of the first element was similar to the property of the eighth element. So that was all about your Newland's law of octaves. Mendeleev's periodic table, you all know that the physical and chemical properties of the elements are periodic function of their atomic weights. In Mendeleev's periodic table, remember that the physical and chemical properties will depend on atomic weight, but in modern periodic law, the physical and chemical properties depends upon atomic number. Next, and altogether we have 18 groups. Group number one are called alkali metals. Remember that group number 1 are called alkali metals, like for example sodium, potassium. Group number 2 are called alkaline earth metals. Alkaline earth metals. Group number 15. Group 15, you can remember that they are called, group number 15 are called pnicogens. Group number 16 are called chalcogens. But remember for group number 17 that they are called halogens. And group number 18, you all know that they are called inert gases or noble gases. So remember the names of the particular group. At least remember for group number 1, 2, 17 and 18. Now, the general thing is that what are metals? So you all know that metals are the electropositive elements and they can lose electron. Non-metals are electronegative. They gain electrons. Next, metalloids, we have already discussed that the elements which show some properties of metals and some properties of non-metals are called metalloids. Example, boron, silicon, germanium, arsenic. Now, remember that in a group, what happens? In a group, the number of valence electron will be same. Suppose if you are considering group number 1. So in group number 1, all the elements will have same number of valence electron. In group number 2, all the elements will have same number of valence electrons, right? But in a period, what happened? That number of shells remains the same. In a period, number of shell will remain the same. For example, all the elements which are present in period number 1, they will have only 1 shell. All the elements which are present in period number 2, they will have 2 shells. And all the elements which are present in period number 3, they will have 3 shells. But what happened about the valence electron in a period? A longer period, when you move, number of valence electron increases. Means when we move from left to right in a period, number of valence electron increases. Number of valence electron increases that time. But in a group, the number of valence electron remains the same. But when we move from top to bottom in a group, that time what happens? Number of shells increases. So just opposite you have to write that when in a group, number of valence electrons remains the same, but in a period, number of shells remains the same. In a group, when you move from top to bottom, number of shells increases, but in a period, when you move from left to right in a period, number of valence electron increases. So that is the difference between group and period. About atomic size, already we have discussed. When you move from top to bottom in a group, atomic size increases. When you move from left to right in a period, atomic size decreases. About metallic character, also same trend is there. Along a period, metallic character will decrease, but along a group, metallic character will increase. If we talk about electronegativity, when you move from top to bottom in a group, electronegativity decreases. But when you move from left to right in a period, electronegativity increases. So that's a brief concept I have given you from this lesson. Periodic classification of the elements, the questions which I have provided you over there, these questions are already asked in the previous year. So chances are there that these questions can be asked in the exam. So if you want to read this chapter once again with full concept, then please go to the playlist of class 10. Over there I have uploaded the full lesson, periodic classification of element. Listen to that once, read your NCERT book once. You can definitely score good marks in this chapter. The only thing is that you have to remember the concepts about periods, group, what are the trends which are followed, what is Newland's law of octaves, what is your Mendeleev's periodic table. Those things you should know little so that if the questions will be asked, you can write the answer. Apart from this, if you have any doubt in any of the topic or any chapters notes, any chapter important question, if you want, you can comment in the comment box. I will definitely give you the answer. And apart from that, I have given you a homework over there that tell me that which element is having atomic number 12 and which element is having atomic number 16. Okay, so thank you guys. Thank you for watching, and if you are new to my channel, then please subscribe to it. Do comment in the comment box so that I will also feel motivated and I can come up with the new videos for you all. So thank you for watching.